Okay, so our last round of our last video in 2.2, again we're trying to find linear equations, and there's some nuances in here and we'll work around and some interesting things that happen. So the first one, they're asking us to find the equation of a line that is parallel to a line with an undefined slope and passing through -5/2. Now first off, notice that they're not telling me which equation, right? So slope-intercept, point slope, general, whatever. So I have free reign, so we can use whatever we want. They're telling us that we're parallel, so it means our slope's the same, right? So same slope. But what's interesting, right, is the line that we're looking for, right, is parallel to one that has an undefined slope. So if you're an undefined, how do you be the same slope? Well, remember, right, if you go back a few videos, we have an undefined slope in situations, here's y and here's x, where we have a vertical line, right? So x equals a number. So that basically means we are looking for a vertical line, and our vertical line is passing through -5/2. So let me draw another picture here. So vertical line, right? 1, 2, 3, 4, 5, 1, 2. So what vertical line is going to be passing through that point? Well, the one where x is equal to -5. All right, because that's basically what has to happen. X has to be -5. So again, kind of an interesting feature there, using the idea of what it means to be undefined, right? The fact that our slope has to be the same. This has an undefined slope, and a line perpendicular to it would also have an undefined slope. So interesting language to get a vertical line. 9's kind of similar. We got to find the equation of a line that is parallel, right, to the line given by y equals to 10, right? But this time it also passes through -5/2. So again, y equals 10. What does that graph look like? Right? Here's let's just let that be 5 and let that be 10. Well, y equals to 10, right, looks like that. And right now we have 1, 2, 3, 4, 5, and 2. There's the data point that we are at. So if we're going to be parallel to the line y equals 10, that means I also have to be a horizontal line. Of course, what horizontal line is that? Y equals to 2. All right, so that's what has to happen there. So again, interesting bend on what we have. One case we have a vertical line, x equals a number. The next case we have a horizontal line, so the slope is equal to, or y equals a number. Slope's actually 0, right? So moving right along, now we get into very wordy, almost applications, if you would, right? Real life situations. So we got to find a linear model. All right. Now again, linear model is just another buzzword for equation. So because I'm asking for a linear model, you have whatever you want. You have y equals mx plus b, or you have y minus y1 equals m, right, minus x1. So do you want the slope-intercept, or do you want your point slope? Of course, that'll be driven by what we have, right? Do we have a y-intercept or not? So let's look, right? So the situation is Raymond has signed, that's a cell phone contract with Algebra Solutions, where he is charged a startup fee of $15 and then 1 cent per minute of cell phone usage. All right, so there's basically the situation. So what do we have here? What's the data? And we look at it, there's really not any ordered pairs, right, per se. But the language right here, you guys see the word per? That's classic language for basically a fraction, right? I have 1 cent for every 1 minute of action. Alrighty? And so there is basically our slope. So we're already given the slope. Now we need to know is, what do we have in terms of points? And the key phrase here is we have a startup fee of $15. So the minute usage, right, when the time is equal to 0, right, I basically owe these people $15. So 0.15 kind of sounds like a y-intercept to me. All right, and how about I call that x when x equals 0? So we have a y-intercept, we have our slope. I'm thinking, why don't we just use good old-fashioned y equals mx plus b? And now the next challenge, though, before we go do this, right, this one's very interesting because this is written in dollars and this is written in cents. So we have to be very careful. All right. How about, I think we can convert this 1 cent, right? There's 1 cent per 100 cents, right, in $1. So we're basically talking about 0.01. So now this is dollars per minute. All right. So you say 1 cent per minute. That's the same thing as saying $0.01 per minute. Now we have dollars and dollars. So y equals 0.01x plus 15. And there is our linear model. And we're good to go. All right, and the next one, again, we're asked for a linear model. So again, we get to choose slope-intercept or point slope. And let's look what's given. Right, the situation says the Porter family bought a home in 2007 for $245,000, and in 2014 the home was valued at $105. So obviously it depreciated. What they want us to do, is find the rate of depreciation. I actually want us to find the linear model. I think I miscopied something. So how do I find the linear model for that? Again, if we look at this real closely, there's data points. Right, if we let x be the time, the year, and we let y be the dollar amount, one of my data points is 2007, and I'm going to make that 245, right? We'll just consider this in thousands of dollars when I write it out. The other data point is 214, and it looks like we had $105,000. So I've got two sets of data. It looks to me like we're going to lean towards the good old y minus y1 equals m minus, right, x minus x1. And so finding my slope, here's my x1 and my y1, here's my x2 and my y2. We have 105 minus 245 over 2014 over 2007. I know the bottom is 7, and I believe up here we get 135. Oh, no, 140. Sorry, negative 140. And that turns into negative 20, right? So basically they're losing, right, $20,000 per year. But we'll keep it at the negative 20 since we've lopped off all those zeros. So we're ready, right? Here's my x1 and my y1. Here's my slope. So we got y minus 245 equals negative 20, x minus, and that would be 2007. All right, and there would be your model. Again, x is the years, and y is the dollars in thousands. That's what I'd have to tell somebody if I use that model. Of course, if I wanted the slope-intercept, I would just solve it for y. All right, or one last little trick. This is a very, very famous trick that's used. What we do is we let t equal to 0 correspond to the year 2007. Now, why would I do that? Because that means that this data point, 2007 245, becomes 0 245. And then 7 years later, right, 2014, this becomes the data point 7 105. Very famous trick. All right, and what's good about this is now I've worked in a y-intercept. And the slope's going to be the same, right? It's going to be 105 minus 145, 7 minus 0. So the slope, again, is still going to be negative 20. But there's my slope, there's my intercept. So my model is now going to look like this. Y equals negative 20x plus, all right, 245. And we're going to have to tell people what we did, right? Because we're going to have to say x, right, is the time, right, where x equals 0 corresponds to the year 2007. And then y is still the dollars in thousands. So very interesting real-life application, right? We either use our point slope model and don't really worry about anything, or we use this little trick where we kind of compress the time, right? We let time, actually again, x equals 0. When x equals 0 corresponds to the year 2007, that creates a y-intercept, and we can actually use y equals mx plus b. The challenge, though, is you better let people know what you did so they can use it. For example, if I wanted to know what the price of the home was here in 2020, for this model, I would literally just press let x equal 2020 and do the math. For this model, I would actually have to let x equal 13, right? Because this corresponds, 0 corresponds to 2007, 2020 is 13 years away, so I'd plug a 13 in there. So that's the difference between the models because of what we chose to do. That wraps up our line conversation. Again, it's all about the line forms, being able to graph from them, and then a lot of curve fitting, right? Finding equations of lines for given information. I do believe the book actually has you finding a lot of slope-intercept, which isn't no surprise, but don't be afraid of using the point-slope form first, right? And then using that to help you find your slope-intercept form if needed. As usual, if you have questions, please ask. Jump online. Let's have a great Canvas conversation. Call, let's have an appointment virtually on Zoom, and that way we can talk and actually answer your questions if some of the things that I did weren't real clear. Thank you for all your time and your effort. That wraps up my part of 2.2. You guys need to go do your homework and practice, talk about it, and go take that quiz. Talk to you guys later.